So two parts to the system modeling problems. One is the actual modeling, and that is the stuff getting equations in the time domain and converting to frequency domain. That's what we'll talk about first. Then second is the controller design. How do you choose what the transfer function for the controller should be before you can solve the system? So modeling the plant, designing the controller. So for the modeling, first you draw a free body diagram, then derive dynamics equations, then convert to frequency domain, then find the transfer function. So there's a mass spring damper example that we'll do here. There are other examples in the notes too, the chapter 6 controls notes that are uploaded along with the PowerPoint. But starting out, you draw the free body diagram. So you have the system. We can see there's a force here. There are also going to be a force from the damper and the spring. So then we derive the dynamics equation. So sum of the forces is mass times acceleration. Write all the forces in there. Then convert to frequency domain. So since S is the time derivative, then anywhere you have a ddt, you would put in S. So if you have an x dot, then that becomes x times S. If you have an x double dot, that becomes x times s squared, and so on like that. Then finally, you find the transfer function using algebra. So this is GP because P is the plant, the robot or the machine that you're controlling. So that's what it looks like on this problem. So free body diagram, we have the force going to the right. This is the applied force, so that will be the input. So the input goes on the bottom because transfer function is output over input. And then the output of this system is the position. So force is input, you pull on the block, you get some position output. So other forces here are the damper force, which acts on velocity, and the spring force, which acts on position. So we put all those in here. Input force equals mass times acceleration plus damping force plus the spring force. And then if we put these into frequency domain, we use S as the derivative variable. So this B x dot turned into BS. M x double dot turned into MS squared. And then because X is itself, it's not a derivative, then we don't put an S there. So all that times X equals F. So then to rearrange to get the transfer function, we have the output over the input. So basically you just divide. So we have X of S, then the F of S will go on the bottom. And then this MS squared plus BS plus K has to move to the other side where it'll be in the denominator.